subject of today's tutorials is the SNI reaction with so-called internal nucleophilic substitution. So, what is this all about? It is not the reaction, for instance, of this sodium alcoholate intramolecularly with nucleophilic substitution, SN2 process. Sodium chloride evolves and this tetrahydrofuran. This would be an intermolecular nucleophilic substitution, not an internal. So here we have an example of the internal nucleophilic substitution. So if we have such a secondary chiral alcohol and one enantiomer, and we treat it with thionyl chloride, then this ester will be formed, HCl is eliminated. If we heat this up, then SO2 will be set free and this chloride. And what is astonishing about it, this reaction works under retention. This chloride is on the same position as the oxygen here has been before. So how can we explain that mechanistically? First of all, this carbon-oxygen bond has to break, forming this cation and this counter anion. And now the transfer of the chloride to this position has to proceed very fast within the solvent cage, that those parts have no time to move around, that there's no time that the chloride might attack from the other side. Yeah? Then we have a reaction with retention. But in this case we have to heat it up a little bit, that while the activation barrier can be crossed. On the other hand, the substitution will proceed already at much lower temperature if we have some pyridine present. The pyridine is helpful by the formation of this ester, and the pyridine will trap the HCl. Then we will have a pyridinium chloride. And this chloride will be active to attack as a nucleophile this intermediary product and will undergo a nucleophilic substitution here with a Walden transformation, a typical SN2 process, where at the end the product will be formed under inversion. So from the presence of the pyridinium chloride we will get preferentially the other enantiomer. Thanks for listening.